Hello and welcome back to the AI Research Roundup. I am your host Alex and today is June 10th, 2025. Alright, so today we're looking at a paper from Hugging Face's trending list, published just a few days ago. It's titled Saffron-1, Towards an Inference Scaling Paradigm for LLM Safety Assurance. This paper tackles the critical problem of LLM safety against jailbreak attacks. The authors note that while inference scaling, which is exploring many different possible outputs to improve reasoning, has advanced LLMs, it's been overlooked for safety. They propose a new method, Saffron, which introduces a Multifurcation Reward Model. This new model can predict safety scores for all possible next words at once, making the safety check process much more efficient. Alright, so this first figure really visualizes the core problem and their solution. On the left, we see the traditional approach using what's called a process reward model, or PRM. This is a model that gives a safety score for a sequence. To check each possible next word, like bomb or cake, it has to make a separate, expensive call to that process reward model. Now, on the right is their new method. With just one call to their multiplication reward model, it gets safety scores for all possible next words simultaneously, making it much more efficient. Building on that idea of efficiency, this next chart really drives the point home. It plots the attack success rate, which is the percentage of successful jailbreaks, against the computational cost. So lower is better. You can see their method, Saffron-1, in blue. It pushes that attack success rate way down with very little compute. To reach the same safety level, it needs about 3 times less computation than the next best method, a simpler technique called best of n sampling. This result really highlights the impressive efficiency gains from their new approach. This table then details the head-to-head performance with every method given the same compute budget. We're looking at the attack success rate, so lower numbers are better, on 2 tough jailbreak benchmarks. You can see other defense methods listed, like one using a Monte Carlo tree search, which is a search algorithm that intelligently explores many possible response paths. But look at the bottom row. Saffron-1 achieves an attack success rate of just 0.175 and 0.409. These scores are dramatically lower than all others, proving its superior effectiveness at blocking attacks. So these next charts really visualize why Saffron-1 performs so well. On the left, we see the attack success rate plotted against the required inference compute, measured in TFLOPs, which is a unit of computing power. The green line for Saffron-1 drops sharply, showing it drastically cuts down successful attacks with very little compute. Then, the chart on the right shows how the new Multifurcation Reward Model's safety scores line up with the old Process Reward Model's scores. They form a nearly perfect line, proving the new, faster model is also incredibly accurate. So, to wrap things up, the Saffron-1 approach is a real breakthrough. It pioneers an incredibly efficient way to check for unsafe content using that new multiplication reward model we discussed. This method isn't just faster. It's also dramatically better at blocking jailbreak attacks without hurting the model's helpfulness. They even use a clever try-based key-value caching strategy, which speeds things up by reusing calculations for similar sentence beginnings. That's all for today's AI Research Roundup. Thanks for tuning in, and I'll see you next time.